Hello, my name is Gage Hartwell, and for my capstone, I chose to create a monitoring system for a grow tent with wireless transmissions and email-based data logging. I decided to create this project since in the winter, the cold drafts from the window tend to kill my plants, and if I were to move them away from the window, the low light tends to cause them to grow incorrectly. A grow tent is the perfect solution to this problem, however the environment needs to be monitored to some degree, and commercial products that I've seen don't have a good ratio between price affordability and custom features. The general flow of how my system works is that the transmitting module inside the tent will gather the sensor information, process and package the data, and transmit it to the receiving module in a sequential data packet. On top of this, the transmitting module will have custom thresholds based on these sensor values to trigger relays that control various devices such as an exhaust fan, a circulation fan, and a dosing pump. Upon data reception, the receiving module will then unpack this sensor information, display it to the user via an XDN screen. This is also where the data logger is located, which currently logs to a Linux-based system, in my case the Raspberry Pi, and Python handles all of the emailing. Both systems are based on the Arduino Nano and NRF24L01 wireless transceiver due to the ratio between compact size, features, and functionality. To start, let's go look at the transmission hardware inside the grow tent. So starting with the outside of the tent, you can see the enclosure for the relays here with an on and off switch, power monitor, and the corresponding outputs on top. I'm just using 3 for the moment, but in my future editions I'll be using all 8. The first output device is for the humidity, which is the exhaust fan here. The little knob over there is just to adjust the speed control manually. I'm going to have it automated in the future. The second output device is down here. It's a dosing pump, just a DC motor, and it refills a liquid reservoir. I'm going to apply it to hydroponics in the future, but right now it's just filling my humidifier. So moving inside the tent, you can see the humidifier in the back there with the hose and corresponding sensor. Up in the corner you can see the fan. Over here you can see the transmitting module mounted to the ceiling and the light sensor that's also attached to a cable. I can pull it out to adjust the light, but right now it's just sitting back there since I don't adjust the light past minimum right now. You'll see a bunch of cables coming off the bottom of the transmitter. Those are sensors for soil moisture and they go to various plants. There's one back there, over here, and over here. So to demonstrate this module, I'll just zoom into the screen here. So you can see that there's an LCD and 3 push buttons. What this allows me to do is to adjust multiple variables such as the transmission interval, which changes in half-second intervals or 500 milliseconds, the upper trigger to the temperature relay, which you can see here, just triggering the fan in the corner here, you can hear it turn on, and you can hear it turn off. Same idea for humidity, follows the same principle, hear it turn on, nice loud fan, and hear it turn off. This one is for the humidifier. It works on the same principle. It works really slowly, so it's a little harder to demonstrate, but it's, as I said, the same principle. And then the soil probes, which aren't hooked up to relays right now, but they do have the capability of functioning. And this is the low trigger for the humidity relay, and essentially how this value works. Say the upper trigger is set to 60, this one right now is at 3. It would be 60 minus 3, so the lower trigger will be 57. And then it would be 58, 59, etc. And then the last button press will just turn the screen off. It also features an auto timeout feature for if the buttons are not pressed. And that is the bulk of how the transmitter works, so moving to the receiving module. So here you can see the primary receiving module, or the NextDN hub as I like to call it, and this is the primary homepage that almost all of the sensor information will be displayed. Starting at the top left, you can see the dust levels, and it's measured in molecule size per volume of air. Underneath there is the relay status. 1, 2, and 3 are the fans and dosing pump. 4, 5, and 6 are the rest of the analog sensor values. They aren't hooked up to relays right now, but they do trigger on and off based on the thresholds. 7 and 8 are unused. In the future, I intend on using all 8 relays, plus some more flexible controls, such as speed control via PWM to the fans. To the right of there, you can see the air pressure and the light level. The light level is also reading the intensity of the light and will display to the user if the primary light is on or off. It does not control the light, it is read only. To the right, you can see temperature and humidity with 3 values stacked on top of each other. The top one is the on trigger for the relay, the middle one is the off trigger for the relay, and the bottom one is the delta. What the delta is, it displays the difference in value from the current listed one from the previous listed one. It's a little bit buggy for some values, as you can probably see with humidity bouncing around. It doesn't always list the small jumps, but it does list the big jumps pretty accurately, and it's very handy in telling if the fan is set to too high of a speed. At the top, you can see the diagnostic information for the transmitter. At the top right is the set point interval in milliseconds, so it is set to transmit every half a second. Underneath there, you can see the time it took for the packet to come in. To the left, you can see how many retries the transmitter tried to send the packet. Underneath, you can see if an entire packet has failed. To the left, you can see the real-time clock, which the top one is the real time, and underneath is the time that the most recent successful transmission was received. Moving to the alarms page, you can see that there's nothing listed at the moment. It only triggers on active alarms, which I will demonstrate in a moment. But to see the rest of the sensor value, we will go to the moistures page, which the top row is going to be dedicated in the future to hydroponic plants, but right now it is mostly just monitoring my humidifier. And the bottom will be dedicated to soil-based plants. So moving to the settings page, you would just tap anywhere on the screen that isn't a button, and it'll bring you here, which lists various information such as the baud rate and if the data logger is on or off. Right now the data logger is on, and you can see behind the module it's just data logging to PuTTY through my Raspberry Pi. There are various custom interfaces via email for the data logger, but it takes too long to demonstrate, so I'm not going to demonstrate it, unfortunately. However, this button is also color-coded to signify if it's on or off, along with the text above it. Over here is the brightness control for the screen. It's set to minimum because it's usually pretty bright once you get to the higher levels. And over here is the real-time clock. To adjust the alarm thresholds, we'll go to Settings 2, and you can notice various values. The upper one is for the soil moisture and hydroponic. There's only one value that isn't set to alarm, so there's only 3 of the analogs here. Underneath, you can see temperature and humidity. They have 2 triggers, an upper and a lower. The leftmost is the upper trigger, the rightmost is the lower trigger. To demonstrate the alarms, I will trigger both of them on temperature. So I'll just bring the upper alarm down to trigger, and then I'll bring the lower one up to also trigger. They will trigger at the same value, and you'll notice that everything turned red. So to make everything not go red, you'd either have to reset or toggle alarms or check the alarm. And you'll notice if you go to another page, that alarm stays active until you physically check it. And as you can see under temperature, you can see the high and low are listed to the same, since that is where they are set to trigger at this moment. And to clear that, since I left the triggers active, I'm going to have to toggle the alarms, signified in red that they're off, and reset to clear them. And that is the bulk of this module. I hope you really enjoyed it, and I'd be happy to answer any questions.